All right, 1.3 enzymes. Let's get started with this. 1.3.1 enzymes. They are specific for their substrate, and they increase the reaction rate by lowering activation energy. And we have all these down here that we don't really need to know right now because we will be getting into them. Enzymes are important for metabolic pathways. The definition for metabolic pathways is a chemical reaction that has multiple steps. So, enzymes are important for a chemical reaction that has multiple times. As you can see, this would be a metabolic pathway. You'd have the first substrate. This is the reactant, the first reactant. And after it is catalyzed by enzyme 1, it turns to product 1. But remember, this is a metabolic pathway, so it has multiple stages. So product 1 will then be catalyzed by enzyme 2, and that will go to product 2. And likewise, you go to enzyme 3, and if you have more, you just repeat this process until you get to the final product. And now, this is really important. Each step requires a different enzyme because each substrate has a different shape. What we call substrate is the thing that enzyme is aiming to change. Enzyme always have a thing that it acts on. Enzyme makes something split up or makes something bind together. So the target of that enzyme would be called substrate. And each step requires a different enzyme because each substrate has a different shape. Here, because the enzyme 1 is acting on the first substrate, enzyme 1 needs to have a specific 3D shape that matches with the specific 3D shape of the first substrate. So these two can actually bind together so the enzyme can start catalyze. And likewise for product 1, which is also a substrate for enzyme 2, they need to have the matching 3D shape to be able to bind together and start the chemical reaction. If you take enzyme 3 and product 1, these two will never go together because they will have different specificity. Now, specificity means the specific 3D shape of the active site. Okay, so the key here is an enzyme is specific to its substrate because of specificity, which is the 3D shape of the substrate and the enzyme. Note to remember, enzymes are reused. Enzymes are not part of the reaction, so you won't see enzyme as part of the reaction, as part of the reactants, because enzymes are not used up. Enzymes don't turn to the product. Enzymes help the reactant turn to the product. All right, induced fit model. And I thought to add some fun font to change up the flavor to sauce it up. Active site. Active site is the 3D space on enzyme where substrate locks into. So let's see. On this diagram, the active site would be this part on the enzyme. Remember, active site is the 3D space on enzyme. And an active site would have specificity. This means an active site will have a specific 3D shape that will only lock into one specific substrate. And now we get to induced fit. Induced fit is when enzymes conformation changes to more tightly fit substances. This facilitates breaking by putting pressure on bonds, building by bringing two small substrates together. Now my biology teacher shows this by breaking a pencil, literally breaking a pencil in half. So he would take a pencil and he would put it between his two, so he would form a surface for the pencil to fit in using his thumb and his index finger. So he would use those two fingers and make a platform for the pen to fit in. And then after the pen is lying horizontal on her, I mean on his fingers, he would then grab tightly around that pen, and that is basically induced fit. Induced fit is when enzyme is conforming to the shape of the substrate. And you can picture this by imagining that it's grabbing tightly around the substrate to better fit it tightly. And then my biology teacher would just grab it tightly and then apply pressure enough to break the pencil. And he would call that breaking by putting pressure on bonds. And enzymes don't just break things, they can also join things. They can build by bringing two small substrates together. And that is literally the opposite of what you see here. You have two reactants fitting, induced fit, which means the enzyme is uh, conforming its shape to the substrate, and then it comes out at one. Active site conforms to the substrates, bringing them closer together, allowing bonds to form easily. And this is how enzyme lowers the activation energy by making the bonding or the separating easier using lesser energy. Enzymes and energy of reaction. Enzymes lower the amount of energy required to get a reaction to occur. How? Well, they put pressure on the substrate bonds, so it's easily broken. They force two substrates together, so they are easily joined. All right. Factors affecting enzyme activity. Influence of temperature. Now, there are three factors that affect the enzyme activity. And there are two, well, there are actually another three that affect its, what is it? It's the rate of enzyme reactions. And we will learn the difference later. But without further ado, influence of temperature. At low temperature, enzyme activity increases quickly as temperature increases. Why? Kinetic model says they move faster with more energy, and so substrate will collide with active site more frequently. What that means basically can be portrayed from this diagram, from this graph here. At low temperature, an increase in temperature will lead to also an increase in enzyme activity because we know from chemistry that increasing the temperature will make the reaction rate happen faster. Well, why does that happen? Because when you heat something up, the molecules and the atoms in that thing is vibrating a lot faster. And since chemical reactions is basically things reacting with things, when you have small molecules floating around a lot faster, they are a lot likely to collide into each other and cause that chemical reaction. Same thing here. If enzymes move around a lot faster, they are then a lot likely to collide with the substrate. And that makes the reaction rate faster at low temperature. And of course, like everything, it has an optimum temperature. When it's over that temperature, the enzyme starts to lose some of its activity because some enzymes will denature. Denature means the losing of specificity. When you heat up an enzyme to a temperature too high, it will cause the bond in that enzyme to break. So it will change the shape slightly if you just heat it up a bit, but if you like boil it for 10 hours, the enzyme will be completely messed up. It will lose its shape entirely, and therefore, since its shape, its specificity is so important, the enzyme will no longer um, do catalyzing. Enzyme reaches maximum optimal temperature. So there is a max optimal temperature, which is the optimum temperature that the enzyme functions the best at. Too high of temperature will change the structure of the active site, leading to denature, and substrate cannot bind to the active site anymore. It will then quickly loses its function if you keep heating it up. Influence of temperature. Okay, this is just another diagram to show the same thing. It's basically the same diagram. Shows too cold for enzyme to operate, so there is no enzyme activity at 20 degrees for this one. And the optimum temperature for this enzyme is around 34. And this enzyme denatures at high temperature. Optimum means where the enzyme is most active. Now another influence is pH. If pH is above or below, enzyme denatures and substrates can bind. This is like the same thing for temperature. pH of 1 means it's too acidic. pH of 10 will mean it's too basic. Now, different enzymes have different desired pH conditions that it works under. In our stomach, for example, which is full of stomach acid, the enzyme in our stomach will be very acidic prone, and it functions under a pH of around 3. It's just fine living in our stomach. But if you take that into another environment like small intestine, which I think is basic, your stomach enzyme wouldn't work well in a basic environment because its optimum pH is around 3. And a pH of 7 would not be a pH of 8 would not be very good for its enzyme activity. So pH can also affect the shape of substrate. If it's too much, most enzymes denature. If it's too low, most enzymes denature. Different pH optimal values for different enzymes. All right, next thing. Influence of inhibitors. There is competitive inhibitor and non-competitive inhibitor. Competitive inhibitor, now this is a new topic. Inhibitor basically fights for the space in active site. The active site is meant for the substrate, for the enzyme to bind to. But there are things called inhibitors that can attach to the active site, thus kind of stealing the space of the substrate. So when a substrate comes, usually it would just naturally bind into this position. But since this is now taken up by a competitive inhibitor, a substrate cannot bind to the 3D shape of the enzyme. So you just have this bind to an enzyme, which doesn't do anything because this isn't a substrate. And there is another type called non-competitive inhibitors. These bind to the allosteric site, which is not the active site, but a site that non-competitive inhibitors bind to change the specificity of the active site. So you have this little thing coming in, binding to the allosteric site, not the actual active site. But this little thing, this non-competitive inhibitor here, will actually change the shape of the active site, so it will lose its specificity. Now, since specificity is so important for enzymes to bind to substrate, when it changes, the substrate loses basically access to binding to the enzyme. So there are two types, competitive and non-competitive. And inhibitors basically can disable the function of an enzyme. And there are also three influences that affect the reaction rate. They don't directly affect the enzyme activity, but they can have they can have influence on the rate of reaction. Now, This is very special because if you go to the next slide, we will see that there are three factors that affect rate of enzyme reactions. But in the learning curriculum, which is the official learning material that South Australian government has designed for the student, uh, in the learning curriculum, we only need to remember two, and the third isn't really needed. But what's so bad about learning one more thing, right? There are three factors that affect the rate of enzyme reactions. First two are pretty simple. The concentration of reactants and the concentration of all the substrates. If you have more reactants and more substrates in a test tube and with the same amount of enzyme, they are more likely to run into each other and bind to have reactions done to it, right? If you just have one enzyme and one reactant in the same test tube, they will probably never run into each other because they are small molecules. An enzyme is small, a reactant is small, and in a vast space of a test tube, they are very not likely to run into each other. But when you increase the concentration of the reactants or the enzyme, this time they are a lot likely to run into each other. Since reaction basically happens by them binding together, uh, if there are less of both uh, reactant and enzyme, they are less likely to run into each other. Thus, the rate of reaction would be a lot slower. And this is very straightforward. And third, you have reaction concentration of certain products, which is the slide before. Influence of concentration of products. So this is another what's the word called? Metabolic pathways. I need to remember that word. I don't even know that word, even though I'm learning. All right, metabolic pathways. You have the initial substrate, and after it has attached to enzyme one, this is turned to product one, product two, and the end product. However, sometimes since chemistry is so unpredictable, the end product of the end product here may bind to enzyme one. Now, enzyme one, if you remember, is meant to do the job of catalyzing initial substrate. Now, if you have a bunch of end product produced after this metabolic pathway, some of the end products will actually bind to the enzyme one, which is meant to do the job for initial substrate. Now, since there are limited numbers of enzymes, lesser free enzymes means slower reaction rate if, because that would decrease the concentration of enzyme and therefore decreasing the effect rate of enzyme reactions. So sometimes this can happen, but this is not in the curriculum. And yeah, that's it. I think that's everything we have. Pretty good. Pretty pretty good. All right, that's it. Thank you for watching 1.3 enzymes. Enjoy your day. Enjoy biology.